Thank you to Planet Wild for sponsoring today's episode of SciShow. Planet Wild helps our planet bounce back from ocean pollution, deforestation, and species extinction, one mission at a time. You can learn more about Planet Wild by watching the video recommended at the end of this episode. Fiber optics have given us everything from novelty desk toys to the internet. But like a lot of technology that humans came up with, nature may have gotten to it first. Several species have body bits with some interesting fiber optic properties, but there's one animal that stands out as the cutest. Over the decades, scientists have argued about whether polar bear fur is a version of fiber optics, one they use not to send WhatsApp stickers, but to help keep themselves warm. Fiber optic cable is pretty incredible. It's basically a tube made of two different materials. For fiber optic internet, it's usually a glass core surrounded by a special kind of plastic. And to send light around the world, it takes advantage of a physics principle called total internal reflection. When light hits a boundary between two different media, like glass and plastic, or plastic and air, there's a chance some of that light gets reflected, and some doesn't. But assuming it starts off traveling through a denser medium, and it hits the boundary at a shallow enough angle, then all of the light reflects. In other words, the beam can bounce all the way from one end of the tube to the other without some of it leaking out. Humans can also encode information into light waves, so we can quickly and efficiently shoot not just light, but data down fiber optic cables. And while our global communications network needs modern technology to craft the perfect glass to keep our signals strong, total internal reflection isn't very difficult to accomplish over a distance the size of, say, an animal hair. So the idea that nature stumbled into evolving its own fiber optic cables isn't as impossible as you might think. For example, the individual hairs of those totally adorable but totally deadly polar bears do resemble a fiber optic cable. Each of their outer layer hairs is a hollow tube. And while replacing glass with air drastically weakens the fiber optic effect, light does bounce around a little bit in there. The question is whether it's enough to do anything useful. Back in the 1970s, some researchers noticed that polar bear pelts reflected much less ultraviolet light than they were expecting. One explanation, provided by another team, was that the missing UV light was being bounced along the hollow core of the polar bear's hairs to deliver it to the lower layer of fur. That layer is made up of more densely packed, softer fur, helping it trap the extra heat carried by sunlight and keep it right up against the bear's skin. And by the way, that skin is practically black, which also helps them absorb as much light and heat as possible. But polar bears might not just have fiber optic fur to trap heat. Other researchers have claimed that it can help them sense heat too. That's because the light would scatter differently depending on the angle it hits the body, creating a temperature difference. In principle, the bear could use that to tell where the sun is in the sky, even on a cloudy day. However, all this is pretty controversial. For one thing, you may have noticed that polar bear fur is great at scattering light. While each individual hair is transparent, they scatter all colors of light. So the whole pelt looks white, and the bears get to rock some Arctic camouflage. And that's kind of the opposite of what we want to happen in our own fiber optic technology, where light is sent from one starting place to another very specific end place. Some scientists have tested those hollow hairs and concluded that light doesn't travel far enough down them for the fiber optic effect to be useful. In fancy science terms, the stuff that polar bear fur is made out of is too lossy. Yes, that's a word. But others have argued against these claims, saying that while a single hair might make for a very terrible fiber optic fiber, if you look at how a bundle of hairs works together, you can make up for that lossiness. Yep, scientists use that word too. If you consider an entire patch of polar bear fur, the light could travel down one fiber for a bit, then bounce over to another, and go down some more, and so on, until it gets to the lower layer of fur. This would explain how some light gets directed down to the skin, while some gets bounced all the way out to make the bear look white. So maybe scientists need to expand their idea of what fiber optics look like in nature. But a lack of consensus on polar bears hasn't stopped some people from adapting the properties of their fur into new tech. In 2023, a team from the University of Massachusetts claimed to have combined different plastics to make a wearable, artificial version of this fiber optic fur that keeps you warm. Just like with polar bears, these synthetic hollow fibers are only one half of the story. The other half is a darker under material that absorbs the heat from the light that gets scattered down to it. As long as you're in direct sunlight, the team claims you could be comfortable in temperatures 10 degrees Celsius cooler than if you were wearing only cotton. While the whole direct sunlight thing is a bit of a limitation, the team suggests that future iterations of the design will be more efficient and could even work with ambient indoor lighting. We might never be as cute as a baby polar bear, but one day we might get to rock some fashion that lets us stay just as toasty. This SciShow video is supported by Planet Wild, a community that helps our planet bounce back from ocean pollution, deforestation, and species extinction. Every month, the Planet Wild community goes on a mission to conserve nature. These missions are vetted for effectiveness, lasting impacts, and partner track record, so they're really making a difference. For example, they went on a deep dive ocean cleanup at 40 meters below the sea. And on another mission, they transformed a massive dying forest into a strong, climate-resilient ecosystem. You can see it all in these 2 videos on their YouTube channel, where they upload their conservation efforts for education and 100% transparency. Their videos are all educational with a focus on real-world action, and it's all driven by a community that anyone can join. And thank you for joining us at SciShow.